Good afternoon, everyone. Today I'm going to talk about salinization. So, what is salinization? Soil salinization occurs when water-soluble salts accumulate in the soil to a level that impacts on agricultural production, environmental health, and economics. In the early stages, salinity affects the metabolism of soil organisms and reduces soil productivity. But in advanced stages, it destroys all vegetation and other organisms living in the soil, consequently transforming fertile and productive land into barren and desertified land. So basically, salinization is when there is too much salt content in the soil that can affect the land. Next, types of salinity. Primary salinity came from rainfall over many thousands of years from the weathering of rocks. Examples of naturally occurring saline areas include salt lakes, salt pans, salt marshes, and salt flats. Primary salinity occurs naturally in soils and water. Secondary salinity caused where groundwater level rise by clearing of perennial vegetation in drier areas. It is also the process where salts stored below the surface of the ground are brought close to the surface by a rising water table. Secondary salinity is salting that results from human activities. And lastly, tertiary salinity. It is the rise in saline groundwater and the buildup of salt in the soil surface in irrigated areas. It is caused by using large volumes of irrigation water that locally raise groundwater levels and mobilize salt. Next, we have causes soil salinization. Dry climates, dry climates and low precipitations when excessive salts are not flushed from the water. Next, high evaporation rate which adds salts to the ground surface. And lastly, poor drainage or water logging when salts are not washed due to a lack of water transportation. Soil salinization happens either naturally or because of improper anthropogenic activities, particularly farming practices. Next is the effect of salinization, and I have here plant growth. Salinity becomes a problem when enough salts accumulate in the root zone to negatively affect plant growth. Excess salts in the root zone hinder plant roots from withdrawing water from surrounding soil. This lowers the amount of water available to the plant regardless of the amount of water actually in the root zone. For example, we have here mama plant and papa plant. Mama plant and papa plant is compared into two identical soils with the same moisture levels. Mama plant receiving salty water and papa plant receiving salt-free water. Papa plant is able to use more water from the soil because it receives salt-free water, while mama plant is having problems because it receives salty water. In fact, when the soil salinity levels are high enough, the water in the roots is pulled back into the soil. The plants become unable to take in enough water to grow. So, soil salinization is a widespread problem and a major abiotic constraint affecting the global food production and threatening the food security. And how do we prevent that? Here are some prevention of soil salinity. Increase drainage for better flushing to remove salts from the ground surface. Plant salt-tolerant crops to manage economic risks and to ensure land cover. And lastly, remove salt crystals from the surface mechanically. Moving on to the last, the sources of salt. Where does this salt come from in salinization? You have here irrigation water, rainwater, and weathering. Irrigation water. All irrigation water, especially recycled wastewater, more or less contains certain amount of salts. Every time a farmer irrigates a crop, salt ends up concentrating in the soil. Next is rainwater. Ocean salinity is mainly caused by drain washing mineral ions from the land into water. Carbon dioxide in the air dissolves into rainwater, making it slightly acidic. When rain falls, it weathers rocks, releasing mineral salts that separates into ions. And lastly, we have here weathering. Salt also works to weather rock in a process called haloclasty. Salt water sometimes gets into the crack in pores of rock. If the salt water evaporates, salt crystals are left behind. As the crystals grow, they put pressure on the rock, slowly breaking it apart. This is the end of my presentation, and thank you for listening.